Alright, so the last video that we're going to do for this week is the factor theorem. Now, the factor theorem is very similar to the remainder theorem, except it involves trying to make or turn our polynomial into a factor, or trying to factorize the polynomial. So, suppose that we have a polynomial, so something like, I don't know, x squared plus 4x plus 5, something like this. Then, if we were to take some factor, actually, you know what? Let's make it even easier, something that I can actually do. X squared plus 4x plus 4, okay? Then, let's say if we wanted a factor, so let's find some factor. This is a factor if and only if I substitute this value into the polynomial and get it to be equal to 0. So what I mean by that is, if we have a look at this one up here, if I say, okay, I want to see if x minus, well, not alpha, I want to see if x minus 2 is a factor of this polynomial here. What I'm going to do is I'm going to try putting 2 into this equation. Okay, so it's going to give me 2 squared plus 4 lots of 2 plus 4. And if this is equal to 0, then it's a factor. So this is 4 plus 8 plus 4, which is equal to 16. So that means that therefore 2 is not a factor, or x minus 2. But let's say I want to test, I don't know, x plus 2 as a factor, okay? So that is, I'm going to try p of minus 2. So that's going to give us minus 2 squared plus 4 lots of minus 2 plus 4, okay? Now putting this in, we get 4 minus 8 plus 4, which is equal to 0. So therefore, x plus 2 is a factor of x squared plus 4x plus 4. And that's basically what it means. Okay, so all you need to do is substitute it in, and if you get it be equal to 0, then it is a factor. Okay, so let's have a look at the example for this one. And I promise you there's only one of these ones, not two that I'm going to forget about. So what we're going to do is we're going to show that x minus 1 is a factor of p of this. Okay, so to show that this one is a factor, okay, what we're going to do is we're going to work out, well, if x minus alpha means alpha is a factor, then, x minus 1 means 1 is a factor. That's all it means. Okay, so if x minus 1 means that 1 is a factor. So what we're going to do is we're going to substitute our value of 1 into polynomial. So it's going to be 1 cubed minus 7 lots of 1 squared plus 8 lots of 1 minus 2. And now because I'm lazy, we're going to, we'll do this one. So 1 cubed is equal to 1 minus 7 plus 8 minus 2. And that's a weird looking 2. I'm going to rewrite that one. Okay, so 1 minus 7 is minus 6 plus 8 is equal to 2 minus 2 is equal to 0. So therefore, x minus 1 is a factor of, and it was x cubed minus 7x squared plus 8x minus 2. Okay, and that's it. So x minus 1 is a factor of that. Okay. Now, the next part is divide p of x by x minus 1 and factor p of x completely. So this is what I was talking about in the division of polynomial, where I said we need to do it in factored form. This is where this is going to make a big play. So we've got x cubed minus 7x squared plus 8x minus 2, and we're going to divide that by x minus 1. Okay? So we're going to start off by doing x cubed divided by x, which is equal to x squared, okay? Then we're going to multiply x squared by x to get us x cubed, x squared by negative 1 to get negative x squared, okay? And then we're going to subtract the 2. So x cubed minus x cubed is 0, minus 7x squared plus x squared in this case will be minus 6x squared, and the other ones are going to fall down like this, Okay, now we do the same thing. So minus 6x squared divided by x is equal to minus 6x. Minus 6x times x is minus 6x squared. Minus 6x times negative 1 is plus 6x, okay? And then we're going to subtract these two as well. So 0, 8x minus 6x is 2x, and then the minus 2 comes out like this. Okay, then our last step is 2x minus 2 divided by x minus 1. So 2x divided by x is equal to 2. So we're going to do the plus 2 like this, okay? And once we've done that plus 2 like that, what we can do is we can multiply the 2 by the x to get 2x, and then multiply the 2 by the 1 to get minus 2. If we subtract these two from each other, well, you should know what this one is equal to. And we get no remainder there. So, when I divide x cubed minus 7x squared plus 8x minus 2 by x minus 1, we get the answer x squared minus 6x plus 2. Okay, and that's all we get. So therefore, what we're going to do is the factored form of, okay, and it's x squared minus 6x. Oh, not that bit, sorry. The factored form of x cubed minus 7x squared plus 8x minus 2 is equal to. Now, it's going to be we can start off by either the divisor or the dividend. I'm going to do this bit first, so I'm going to go x squared minus 7, minus 6x, I think it was. Yeah, plus 2. And then it's x minus 1. I should also add, and because there's no remainder, we don't have to add anything on the end. I should also add that if we were to, multiply this one back out, so I do this times this, this times this, this times this, this times this, and that times that, and that times that, you would end up back to this, okay? So this is a way for us to factorize these things without having to worry about all that nitty-gritty stuff that we, well, sorry, not with all the nitty-gritty stuff, but like, it allows us to factor things that we haven't been able to factor before, okay? And then we can look at all this stuff here and look, at the zeros for these things. We can look at the roots of the graph, and we can do all sorts of stuff with this. But this is one of the big steps for allowing us to actually be able to work with these polynomials, okay? So that's it. That's the whole question done. That's the factor theorem done, and the remainder theorem before. And so that's going to finish us up for this video. So I will see you guys in the next one. Talk to you soon.